Today is the last day of the month. It is 8/31/22. The agenda's on the sideboard. You've already completed your warm-up. We're going to go over that real quickly. I've already checked your homework. We did a homework check. We already talked about the procedures and the rules. When you first come into the classroom, you drop off your cell phone. At that time, if you need a calculator, you pick up your calculator in the back of the classroom. It is your desk number. Your calculator number and your cell phone number are your desk number, your chair number. And that's on the back and front sides of your chair. Okay? All right, after which we're going to take some notes on the real number system. Okay? We're going to do a true false activity. And we're going to talk about time management today. We're going to have a discussion on time management. Time management is super important because we have a lot of extracurricular activities and educational things that we have to attend to. We have a lot of more responsibilities as we get older. So we want to make sure that we manage our time appropriately so that we can be successful. Okay. Our homework for tonight, we're going to label as Wednesday's homework. Remember, your homework help video is on Canvas if you have access to Canvas. If you don't have access to Canvas, then I will be sending it to you in Remind as well. Remember to log into Remind. You can download the app, Remind app, and log in with Google, or you can go to your computer and type in remind.com and still log in with Google. Once you log in with Google, which is your school email address and password, then you will have access to Remind with all of your classes. Questions, comments, or concerns? Is everybody okay? Okay. Anyone still writing the homework? Writing the agenda is optional. Writing the homework is mandatory, okay? All right. Let's go to the warm-up. Mark this out. I'll give you something different tomorrow when you come in. It's a slip of paper that I'm going to give you for the warm-up tomorrow. Please mark out the bottom. All right, let's look at the warm-up. Here is distributive property. That's where you have a number or a term that is being multiplied to a group of numbers or terms. When we multiply 5, we're going to multiply 5 times both terms in the parentheses. What's 5 times x? 5x. This is another way to write multiplication. What is 5 times a positive 3? Very good. Positive or negative? Positive 15. I'm going to circle my answer. Raise your hand if you got that right. Distributive property is good. We're going to do the same thing again. We're going to multiply negative 7 times both terms in the parentheses. What is a negative 7 times a positive 2a? Negative 14a. Another way to write multiplication. What is negative 7 times a negative 5? Positive 35. So that's going to be plus 35. Raise your hand if you got this right. All right, wonderful. Okay, let's look at number 3. All right, we're going to do distributive property again. We're going to distribute the negative. Okay, we're going to distribute the negative. All right, we're going to bring down the 10. What is negative times a positive 6m? Negative 6m. What is a negative times a positive 7? Negative 7. Now we're going to combine terms that are alike. What terms are alike here? Like terms. Positive 10 and what else? Negative 7. What's positive 10 plus or just a minus 7? What is that? 3. Positive or negative? Positive 3. Positive 3. And then what's left? Negative 6m. What's another way to write this answer? 6m minus 3. Negative 6m. What else? Plus 3. Make sure you take the sign with it. Okay. Any questions? Raise your hand if you got that right. Okay, a little bit less this time. That's okay. Practice will take care of that. All right, here, the first thing is distributive property. What are we going to distribute here in this problem? What are we going to distribute here?
9 and 2.
Oh, well, we could do that first. We can add this. What does that give us?
11.
And let's bring everything else down. Oops, got my parentheses. Sorry, y'all. Okay, so now when we distribute, we're going to multiply 11 times both numbers in or both terms in the parentheses. What's 11 times 8?
88.
What's 11 times a negative or minus 3 y? And what do we do? Very good. Bring down the minus 1. What are we going to do next? Very good. Combine like terms. We got 88 and what else? Negative 1. What's 88 minus 1? 87. And then what else is left? What's another way to write this? Very good. Raise your hand if you got that right. Okay. All right. We're working on it. Any questions about anything? Let's label the homework. Anybody still writing before I move on? Okay. All right. Let's label the homework. We're working on decimals. Okay, so we're going to be adding, subtracting, multiplying, and dividing. We're going to use order of operations to add, subtract, multiply, and divide these decimals tonight. Okay? All right, so we label this as Wednesday's homework. And Wednesday, again, is 8/31/22. Any questions? Don't forget that if you need some additional help, you can also text me and remind. Okay? Any questions, comments, or concerns? All right, where are we going to put this in our folder? Very good. Let's take out our interactive notebook, composition notebook, and let's place our packet on the side that says work to do, okay, y'all? If I move too fast, just slow me down. Raise your hand and say, Miss Reyes, could you please slow down, okay? All right. Let's make sure that we have everything labeled. I'm going to take the time to make sure that the pages are right. We're doing this because the interactive notebook I'm going to put on Canvas, and they have to have page numbers so you'll know if you're missing a day, oh my goodness, I need to go and copy those pages, okay? Remember, the interactive notebook, I do grade in person. Everything has to be in your handwriting, okay? So you can't copy my work and make it your own work. Any questions, comments, or concerns? Okay, a couple people still getting organized, so I'm going to just pause so everybody will be with me. Let me pause real quick. All right, so we're going to number these pages. In the corner, we're going to put Q1 because remember, we're keeping this notebook the entire year. So you need to know that the pages that we're doing in quarter one. So on every page in quarter one, we put Q1 in the corner. On every page in quarter two, we put Q2 in the corner, and so on and so forth. This is page 1. I'm going to abbreviate page and put PG. And this is our intro page. And that way, if somebody's missing it or it falls out, they will know on Canvas to click on page 1, the intro page, if they need it again. Okay? If I move too fast, then just raise your hand and let me know. Page 2. Page 2 is the syllabus. In the corner, we put Q1. You can spell it all the way out, or you can abbreviate PG for page 2. And this is syllabus. Okay? This are the percentages here. This is super important. These are a list. We basically cover just about 2 units per quarter. We won't finish unit 2 because unit 2 is about 10 or 11 weeks long. So that spills over into the second quarter. Okay. So you'll know. All right. But we will finish it in the second quarter and move on to the next unit. All right. And I will probably do systems unit actually has been moved down to the last unit. We'll do exponential functions first, then quadratic functions, and then last we'll do the systems. Why they moved it like that, I don't know. Okay. Page 3, PG3. Okay. These are our rules. That's the title of this page. These are the expectations. This is what should basically all of your teachers be preaching. When you come to class, you need to come to class prepared and ready to learn. These are the different expectations. I've already talked about some of these things without reading them to you. We've talked about the cell phone policy as well. Hallway procedures have already been explained to you, and so has the locker rules and regs. Page 4, those are your mathematical practices. In the corner, put Q1, PG4. We can abbreviate mathematical by putting math practices. These are different strategies that can be used to solve problems in math, word problems sometimes. Okay, any kind of problem. I will be modeling these, and some of these you automatically do. You don't even think about it, you just do it when you see a problem that's like that. Okay, but if you get stuck, it's always good to go back and look at, well, how could I tackle this? All right. Page 5 are your formulas. These are the formulas that you have to know by heart for your EOC end of course testing at the end of the year. These are your Math1 formulas. The formulas, they're formulas. We're going to be, as we go over them, we'll put them in the list. Like formula for area of a square is S to the second power. Area of a rectangle is length times width. Those you should already know. So on and so forth. That's okay. Yes, baby. Okay. Give me 1 second, okay? And I'll give you another one. Yes, baby. Let me pause. All right. Next page, page 6. That's your goals. Q1 in the corner, PG 6, goals. You should have already completed this sheet. If you haven't, please make sure that you do this at your leisure, okay? Make sure that this sheet is completed before we do our notebook check. Page 7 is the intro to functions page. It's the intro to the first unit. We got Q1, quarter 1, page 7. And this is intro to unit 1. Okay. I've already gone over this page. These are going to be the topics that we cover in the first unit. Those essential questions, just as I told you on yesterday. I make them a little bit more. Sometimes they're a little bit more descriptive and detailed that I give you. These are not always user friendly. Some of them are, and I do post them, but others, I need to know certain things. So sometimes your essential questions will look a little different. But these are the vocabulary words at the bottom for the first unit. Any questions, comments, or concerns? All right, good. Let's move on to page 8. We're going to do our first real set of notes on the real number system. Okay, let me fold my paper back. So this is page 8, real number system. Okay. All right, y'all ready? Okay, so let's put your thinking caps on, please, so we can get this together. Yes, baby. Oh, yeah, that was the slip I did. Sorry. Anybody else need that sheet? You need the sheet.
No, I'm rewriting it now.
You're writing, yes, you're right. Yeah, everything I write. You're gonna be up telling you, Parker, and some of these other little ones. Y'all better get with the program.
I just don't like
I'm trying to tell you, get with it, cause I'm gonna be rolling. Y'all better stay right there. I'm telling you, you better stay right there with me. Don't get lost, boy. Don't get lost. You'll be like, oh, I'm gonna make your hairline go way back here. You better, you better stay with me, Parker. Okay? I know. Bless your heart. You're gonna have to get over it. Y'all gonna have to get over. Well, this is a high school class. I am not joking. We are going to move. Okay? You better come with it. Go hard or go home, okay? Because you don't want us to do one of these. You know what that means? All right, here we go. Loser. All right, come on, let's do it. Shh, we gotta do it. Y'all ready? Stay with me. If I move too fast, Parker, just do like this, okay? Like you at church and you gotta go use the bathroom. Just slip your little finger up, okay? If I don't see you, say, Miss Reyes, could you please slow down? Okay? All right. Okay, now. This ain't gonna be hard. This gonna be easy, but it's gonna be hard if you check out. You know what you feel what I'm saying? If you check out, you start counting sheep in your head, or you start thinking about somebody you like, you gonna miss it.
I just counted things.
I know. You better stop because that thing is gonna cause you to get a straight F. Okay, so don't do that. We ready? Good. All right, so look, real numbers. The first thing we need to know about a real number system is the purpose. I'm gonna put a star beside everything that is super duper important, and you can always go back and use your highlighter when you read your notes. But the purpose of a real number system is to categorize numbers. Yep. The purpose of a real number system is to categorize numbers. We put everything into categories. The reason why we do that is so we can study it, dissect it, break it down, solve stuff. Okay, that's how we find cures to cancer and all types of things, because we have to study it, we have to dissect it, we have to understand the different symptoms, the characteristics, traits, and all of that stuff so we can solve the problems. Okay, so that is the reason why we categorize numbers, so that we can solve mathematical problems. That is the whole reason for categorizing. All right, so let's start with what all numbers are. Any and every number that you can think of right now is called a real number. Okay? A real number. Any and every number. Any and every number is a real number. Any and every number is a real number. Now, later on in life, you're going to go to calculus and they're going to start talking about imaginary numbers. Those are the numbers that are negative, square root of a negative number. Okay? But that's much later on in life. But right now, any and every number you can think of is a real number. So all the numbers that you know right now go under the real number umbrella. Is that your church hand? Okay, you good. All right. Real numbers are broken into two different groups. Okay? Real numbers are broken into two different groups. A real number is either rational or it is irrational. Please write this down, okay? Rational, it's a rational number, or it's an irrational number. A number cannot be both. A number cannot both be rational and irrational. It's either rational or it's not. The prefix is not rational. Like nonfiction is not fiction, okay? What is a rational number? Oh, that's such a good question. Rational numbers are numbers that can be written as a fraction. Numbers, I'm abbreviating numbers, right? That can be written as a fraction.
Can we put numbers? We put hashtag.
Mm-hmm. That's what I did. That's why I said mm-hmm.
Oh, I can't see it.
Okay, baby. Let me slide in.
No,
You might need to come up to the front.
No, it wasn't. It wasn't in the open sheet. Like it literally wasn't in the.
Okay. I believe you. All right. Irrational then. What's an irrational number? Numbers that cannot be written as a fraction. Good, y'all. Numbers that cannot be written as a fraction. Well, Ms. Reyes, what kind of number is that? There are 3 different kinds of numbers that cannot be written as a fraction, okay? And so we're going to list them. And everything that doesn't fall into this category is rational, okay? So I'm going to give you all the possible numbers that could be irrational, and everything else is going to be rational. So let's list the 3 types of numbers that can be irrational. The first type of number that can be irrational are non-terminating decimals. Non-terminating decimals. Oops. Okay. Miss Reyes, what is a non-terminating decimal? Non-terminating decimals are decimals that go on and on forever, but they don't have a pattern as to how they repeat. Okay? Normally what you see in a non-terminating decimal are the dot, 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 dot at the end. Like in the movies where they have to be continued, and what they put at the end to be continued. Those little dots at the end. Okay? So when you see numbers, I'm going to give you an example of what that looks like. You have, let me just do example. You might have 15.238 dot, dot, dot. That means that this number goes on and on forever, and it doesn't have a pattern as to how it's repeating. Since you don't know what number is coming next, you can't write it as a true fraction. Sticking one under a number is not really just writing it as a fraction. It doesn't always work that way. So fractions, decimals that look like that have the dots at the end to be continued. You don't know what number is coming next. That's a non-terminating decimal. Now, this is what people get tripped up about. This right here, and I'm going to write it out to the side. You don't have to write this. When you see a number like this, 4.2525 dot, 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 dot. Okay? What number is going to come next after this, you think? 2. This is rational because I know what number is coming next. Any questions? I know what number is coming next, so that's what makes it rational. I can write this as a fraction. Yes.
Would a non-terminating decimal be like pi?
Pi is the next example. Yes. Okay. Any questions? Very good observation, babe. The second type, he already said it, is pi. Why is pi an irrational number? Why? Yeah. Go ahead. Well, it doesn't matter. Go ahead. And it does not have a pattern as to how it repeats. That's correct. Okay. And a lot of times what you'll see is the squiggly lines. That's about. Okay. Because it's about this number. It's not exact because you couldn't put all the numbers on the page because it goes on forever. Some of us know what the next numbers are in pi, but it goes on forever and ever, and it does not have a pattern as to how it's repeating. That's what makes it irrational. Now, what you do see with pi is they give you a roundabout fraction, 22/7. But remember, it's not exact. They just rounded it to a fraction. It's not the exact fraction for it. There's no such thing as an exact fraction for a number such as pi. You can't just stick a 1 under it and call it a fraction. Yes, baby. I'm going to try, but, it's going to be hard with this pencil, but I'll try. Any questions? All right, I'm gonna move this. So pi is your other. Your next one, breaking this pencil, y'all. Your next one is non-perfect square roots. Does anybody know what a perfect square root is before we talk about the ones that are not or perfect? Well, let's not put perfect square roots. Let's just put non-perfect roots because it could be cube root, fourth root, fifth root, sixth root, seventh root. Okay. Non-perfect roots. Does anybody know what a perfect root is? Does anybody know what a perfect? I'll do square root first. Can anybody give me an example of a perfect square root? Yes. I didn't. I heard 4. Square root of 4. Square root of 16. Yes, both are. Okay. 4 is a perfect square. So the square root of 4 is what? 2. So what do you think makes it a perfect square root? Yes.
A number times itself.
Mm-hmm. A number times itself. There is a whole number or an integer that can be multiplied times itself to give you that number that's under the radical. That's what makes it a perfect square root. Okay? If your square root, if the answer to it is a decimal, that's what makes it a non-perfect root. Can anybody think of some roots that will give you a decimal answer? The square root of what you think? The square root of 7. Perfect. That's a non-perfect root. Yes. The square root, make sure you say square root. The square root of 5. Yes. The square root of 3. Anything larger? Can somebody think of something larger? Yes.
Square root of 15.
The square root of 15. Those are all examples because they have decimal answers. Any questions? Okay, so that means everything else is going to be rational then. If it doesn't fall into these 3 groups right here, everything else is going to be rational. Okay, so that means, slide this just a tad bit, okay? That means your fractions, your decimals, your mixed numbers, your repeated numbers, okay? Your perfect square roots, your perfect cube roots. Everything else that doesn't fall under this irrational is going to be rational. Any questions so far? Okay, if you think of something, just raise your hand and let me know. Now let's go over here to rational. Rational numbers can be broken down into 2 different groups, okay? Either it's an integer, I'm putting integer over here, okay, y'all? Or it's not an integer, okay? It's an integer or it's not an integer. What are your not integers? Decimals and fractions, they go over here. Decimal and fractions, all they can be is real numbers and rational. That's it. If it's a decimal and a fraction, all it can be is rational and real. That's it. Those are the only 2 groups that decimals and fractions fall into. They are a real number because everything is a real number. And they are rational if you can write it as a fraction. That means it doesn't fall in these groups. Now, non-terminating decimals are irrational, okay? But fractions, you already know, if it's written as a fraction, it's rational. Any questions? Okay. Integers are whole numbers and their opposites. I could have used the number symbol, I'm sorry. And sometimes people will say whole numbers and their opposites. Sometimes they'll say whole numbers and their additive inverse. Same thing, okay? Positive, negative numbers, and 0. Positive, negative numbers, and 0 are integers. They do not have fractions attached to them. They do not have decimals attached to them. Integers are whole numbers and their opposites. That is 0, positive 1, positive 2, positive 3, positive 4, positive 5, positive 6, all the way to the positive infinity. -1, -2, -3, -4, -5, all the way to the negative infinity. No fractions, no decimals attached. Questions? Okay. Integers can be broken down into two groups, y'all. Two groups, y'all. Think. What two groups do you think an integer can be broken into? Think about what we are looking at. Negative numbers, positive numbers, zero. What two groups do you think you can break an integer down into? Any guesses?
Odds and evens.
Not odds and evens, not quite. That's a category, but not quite. Yes, baby? We got positive numbers, negative numbers, but then what did we leave out though? Zero. Zero has to have a home. So negative numbers and what? Then you left out all the positive numbers. Let's talk about the definition of a negative number. What is the definition of a negative number? Numbers, I could have put the number symbol there too. Numbers that are less than zero. Numbers that are less than zero are going to be negative. No fractions, no decimals attached here. We got rid of those over there. You can have negative fractions. You can have negative decimals. But remember, a negative fraction and negative decimal is not an integer. It's just a negative fraction or a negative decimal, but it's not an integer. All right? The other group is a whole number. Why do we say whole number, Ms. Reyes? Because whole numbers start at zero. All the way to the positive infinity. So you got 0, 1, 2, 3, 4 to the positive infinity. I should have put irrational in a box, y'all. Sorry about that. Lastly, think about what numbers, what numbers are in the whole number category. How could we break that category down to two different groups? What are you thinking there? Yes.
Odd and even.
No, not quite. What weird number could stand by itself, probably? Somebody said it. Zero. Zero has a lot of characteristics to it. What kind of characteristics? What can we say about zero? Okay, good. And it has no what to it?
Value.
It has no value. Very good, babe. Okay, you said it is the center point of the number line for the most part. It has no value. What else can we say about zero? Since it's in the middle, what do you think we could say about it? It's neutral. What does neutral mean? It's what's neutral? If something's neutral, it's neither what or what? Negative or positive. Zero is neither negative nor is it positive. Y'all remember that? No, maybe so. Yeah, a little bit. Somewhere in that file cabinet back there. Okay. It's a lot of characteristics to zero. It's a placeholder. Does anybody remember that zero is a placeholder? Okay. All right. And then what's the last category? Does anybody remember? It starts with an N. Does that help? You like, no. That doesn't help, Miss Reyes. Natural. Natural numbers. Can anybody guess what a natural number is? Not any. That's a real number. Any and every number is a real number. What's a natural number, you think? It's the first kind of numbers that you learn. Yes, those are counting numbers. It's counting numbers. And when you start counting stuff, what number do you start with? 1, 2, 3, 4. What do they not have attached to them?
Another number.
If you're counting something, this is 1, this is 2, this is 3. They don't have fractions or decimals attached. Okay? We're going to look at the whole view, and then I'm going to do a true false thing with you real quickly. Yes.
Are natural numbers, is it just 1, 2, 3, 4, and 5? Or is it
All the way to the what? Positive infinity. Very good, Parker. And which did I leave out one? Okay, no. Now integers, zeros in the center, -1, -2 to the negative infinity here. And then 1, 2, 3 to the positive infinity on this end. Okay. And now I'm going to go through one more time. And then I got a bunch of questions I'm getting ready to ask you. See if you understand, y'all. See if you got your life together. All right. Let's look at the whole view. Anybody still writing before I go back? You are? Okay. I'm going to pause real quickly. Okay, so any and every number that you can come up with is going to be a real number. All of these numbers are real number. Rational is real. Irrational is real. Non-integers are real numbers. Integers are real numbers. Negative numbers are real numbers. Whole numbers are real numbers. Zero is a real number. Natural or counting numbers are real numbers. Every number is under this umbrella is a real number. That's why all of it is under real number. Any questions about what a real number is? Real number is broken down into two groups. Either a number is rational or it's irrational. It cannot be both. It's either one or the other. Rational are numbers that can be written as a fraction. Irrational, meaning not, cannot be written as a fraction. There are only 3 types of numbers that are irrational that you cannot write as a fraction. Non-terminating decimals. You don't know what number is coming next. You can't write it as a fraction. Pi. You don't know what number is coming next. You cannot write it as a fraction. And I didn't finish writing this. ... Okay. Non-perfect roots. You cannot write these as fractions because the answer is a decimal. You cannot just stick a 1 under these and call it a fraction. It wouldn't be a true fraction. Okay? Everything else, if it doesn't fall in this group, is going to be rational. Fractions and decimals are rational. Integers are rational. Okay? Negative numbers are rational. Whole numbers are rational. Zero is rational. Natural numbers are rational. They're all under rational. Notice how irrational is not under rational. Okay? Rational broken into 2 groups. If it is a decimal or a fraction, it cannot be an integer. Okay? Integers are whole numbers and their opposite. Negative numbers and positive numbers with 0. These are your integers. Integers do not have decimals attached. Integers do not have fractions attached. Integers are broken into 2 groups. Either an integer is a negative number or these integers are whole numbers. Remember, these do not have fractions attached to them. Do not have decimals attached to them. Yes, it's possible to have a negative fraction. It's rational and real. It is possible to have a negative decimal. It means it's rational and it's real. But negative fractions and negative decimals are not integers. They're just negative decimals and negative fractions. Whole numbers do not have decimals attached, do not have fractions attached. They start with 0 and they move to the positive infinity. 0 in natural numbers, okay? They do not have decimals attached. They do not have fractions attached. A whole number either has 0, it falls in this group, and the rest of these numbers are counting numbers. They're natural numbers. Do not have fractions attached. Do not have decimals attached. All right. So now I want everybody to stand up.